Hi, this is Mrs. LaBarbara. Today, I'm going to talk about evaluating experimental results. The objective for today is to know the range and mean, be able to calculate percent error, represent data in graphical form, determine the mathematical relationships for a given graph, determine the shape of graph for a given mathematical relationship. The definition of range is the difference between highest to lowest. The definition of mean is the average for a set of data. For example, a student made 7 measurements of the period of a simple pendulum of constant length. Those are the given 7 values. Determine a range. Well, according to definition, the range is between highest to lowest. So you'll have lowest 1.26, the highest 1.34. Determine mean. Mean is the average. So the average is we add all the numbers together and divide by the total set of 7 measurements. So mean equals to, you add values together, you'll have 1.26, then you have 1.28, you have 3 times, 1, 2, 3. So 1.28 times 3. Next number 1.33, you have that 2 times. So use 1.33 times 2. Then you have 1.34 one time. So you add everything together, divide by 7, you should have 1.30. Second, percent error. Measurements made during laboratory work yield an experimental value. Now you have to compare this experimental value with the accepted value. Accepted value are the measurements determined by scientists and published in the reference table. Percent error is the difference between experimental value and accepted value. That's the absolute difference. So percent error cannot be a negative number. So the difference between experimental and accepted divided by accepted, then times 100%. For example, in an experiment, a student determines the acceleration due to gravity is 9.98 meters per second. If the accepted value is 9.81 meters per second squared, determine the percent error. The equation is this: absolute value of experimental 9.98 minus accepted 9.81 divided by accepted, then the whole thing times 100%. So after you plug everything, you should have 1.7%. Now, when we collect data, most often we have to graph the data to see the relationship between the variables. The data collected in a physics experiment are often represented in graphical form. The graph makes it easier to determine whether there is a trend or pattern, as you can see. So when you do the graphs, it is a trend or pattern, okay? The graph include a title. That's a dependent variable versus independent variable. So independent variable is the one in the x-axis. Dependent is in the y vertical or vertical axis. So it's vertical versus the horizontal. The axes are labeled with quantities and their units. So the next thing is very important is you must use linear scale to accommodate the range of data. The scale has to be linear. Next one, for best fit line, it can be a straight line or a curved line. We know one thing is for sure, best fit line is not the dot and dot connections. Extrapolation means you can extend the line beyond the region in which the data was given. So you can extend beyond, above, or below. These are best fit lines. It can be a straight line like this or a curved line looks like this. You have to see the trend. So one thing is not connecting dots. So best fit line is not connecting dots. Here is an example of a bad graph. What's wrong with this graph? It's the scale. those are not linear, right? From here to here cannot be 29, then from here to here is 9 difference. Those are not linear scales. If the graph is a straight line, the slope often has a physical meaning. So if the graph is a straight line, a lot of times where you are asked to calculate the slope. How do we find the slope? Slope is rise over run. Rise, this would be your dependent variable, the change in dependent divided by change in independent. In determining the slope of the line, you must use the data on the line of the best fit. That's very important. Take a look at this example. All the data, except one, this one you probably can use for you to calculate your slope. The reason for that is because all the other data are not on the line. So how do I calculate slope in this case? You can choose any point on the line. Doesn't have to be the data you have obtained. Then use those 2 points to calculate slope. So here is the case. Slope is change of v divided by change of I. Change of v is the dependent, that's your vertical, divided by change of I, that's your independent. And this difference is 41.5. And the difference in the horizontal is 0.76. So this is exactly how you should calculate slope in your lab report. Here is an example to find slope. So the position of a moving car is recorded in the following table. So these are the tables. Graph the data on the grid provided and draw the line of best fit. So these are the data you graphed according to this, right? Time. This is independent in the x-axis. The position is dependent. Here's the title. Here is the variable with units. And as you can see, the scale is linear. So in this case, you draw a best fit line. Best fit line should be very close to all the data. Now, in order to calculate the slope, you choose the points on the line. So in this case, 0 is, if the graph passes 0, 0, that is always a convenient point. And here is the other point. So make sure you write down the units when you calculate the slope. Next one, the mathematical relationship for a given graph. So once you have your graph, a lot of times you have to infer what is the mathematical relationship between the variables. In this case, they are both a straight line. So the graph is a linear relationship, is mx plus a. So this, in this graph, m is positive. In this graph, m is negative. This one looks like a parabola. So this is called the direct squared relationship, y equals mx squared. Next one, this one is a curved down. We call that relationship an inverse relationship. That means when x increases, y decreases. But it's not a negative direct. Don't confuse these two. This is a negative direct. This is inverse. Inverse is not a straight line. These two graphs have similar shapes. This is inverse squared relationship. It's the difference between these two is that this one comes closer to 0 much quickly than this one. Let's take a look at example. Determine the shape of graph for a given mathematical relationship. The first, this is a direct relationship. We just assume v is positive. You should have a graph looks like this. Direct squared looks like a parabola. Inverse a and m looks like this. This inverse squared again comes down near to the bottom. So that's it for today. I hope it helped. See you next time.